Welcome to the Extreme Networks XNV demonstration. My name is Manny Gutierrez, Technical Marketing Engineer at Extreme Networks. First, let's go over a brief summary of XNV. Extreme Exhaust Network Virtualization, or XNV, is an architecture for virtual machine lifecycle management. It consists of a set of loadable software modules for the Extreme Exhaust Modular Operating System and its Epicenter Network Management Suite. XNV brings VM visibility, control, and automation into the network administrator's domain. Typically, VMs are created, moved, and eventually deleted under the control of the server administrators group, with no VM awareness by the network nor the network administrators. XNV changes this by providing the networking group centralized network-level inventory of virtual machines, displaying their current locations within the network, along with their roaming history. In addition, XNV provides for centralized network profile configuration for VMs, along with dynamic enforcement of these profiles by the network as the VMs move within the network. This is accomplished through virtual port profiles, or VPPs, which can consist of parameters such as access control lists, quality of service prioritization, and metering. It is important to note that XNV does not make any changes to VMs, the VM hypervisor, nor the VM management platform. All configurations along with any changes are strictly on the network side, which is typically under the control of the network administrators. XNV targets the efficient pillar of Extreme Networks' four-pillar solution. The four-pillar solution is Extreme Networks' data center strategy for a phased migration in transitioning from a physical to virtual to a cloud environment. The efficient pillar's purpose is to make the virtualized data center more efficient from a networking perspective. It accomplishes this by providing integration with virtual machine platforms, by providing centralized network profiles for VMs, which are enforced regardless of the location of the VM, by providing heterogeneous support for different VM platforms, and by providing a single pane of glass for network and VM lifecycle management. This slide illustrates some of the issues that virtualization brings to the network. Today, the network is not VM aware, and network administrators have no visibility to the location of a VM or their movement within the network. Consistent configuration and policy enforcement is also an issue. If a VM moves to a host on the same switch or to a host on another switch, there is no assurance that the destination port is correctly configured or that policies on the destination port are correct or even exist on that switch and port. The network admin is completely unaware that the VM has moved. This next slide illustrates how XNV addresses these issues and brings VM awareness to the networking domain. With an XNV-enabled network, Epicenter pulls the VM inventory from the VM management platform and locates the VM locations on the network switches down to the port level. Epicenter then can report the VM inventory, location, and status of the VMs. Epicenter also provides the ability to create virtual port profiles, assign them to VMs, and automatically distribute them to the switches. The network admin does not need to configure each individual switch. When a VM moves, Epicenter reports the move by updating the location of the VM, including which physical host or hypervisor the VM moved to, along with the switch and port information. In addition, the virtual port profile automatically moves to the destination port. The demonstration will show off XNV's lifecycle management features, along with a VM move showing the benefits that XNV delivers. Before showing the demo, let's look at the demo's topology. The demo network consists of two tiers, a Black Diamond 8806 at the core, and two Summit X650 top-of-the-rack switches at the edge. 3 VMware ESXi hosts are connected at the edge, with 2 of the hosts connected to a Summit X650 24T, and the third host connected to a Summit X650 24X. The 10.0.40.10 host is connected to an XNV-enabled port, while the 10.0.40.11 host is connected to a port that is not XNV-enabled. The third host, 10.0.40.12, is connected to the second switch to a port that is XNV-enabled. A virtual machine called Video Server W2K8 is streaming video to a video client that is connected to the Black Diamond 8806. That same client is also used to access Epicenter, vCenter, and the switch's CLI during the demo. The traffic from the video server to the video client traverses a congested uplink. This is true regardless of which host it resides on. A virtual port profile prioritizing the video traffic using quality of service was created and assigned to the VM using Epicenter. The virtual port profile will automatically move with the VM on the XNV enabled ports. Now let's go ahead with the actual demo. On this desktop you see several windows. The main window is the Epicenter Management Console. Below that are two telnet sessions to the Summit X650 switches. These three windows represent the network administrator's view into the network. To the right is VMware's vCenter Management Console, and this window represents the server administrator's view. Above that is a VLC Media Player window, which is a video client that will display the streaming video from the video server VM. Currently, the video server is not streaming any video. Let's take a closer look at the information displayed on vCenter. vCenter is currently managing three ESXi hosts: 10.0.40.10, 10.0.40.11, and 10.0.40.12. And each of these hosts is hosting a few virtual machines. The virtual machine we're interested in is named Video Server W2K8, and it is currently running on the 10.0.40.10 host. This is the virtual machine we'll be migrating as it streams video. From the vCenter console, you can easily initiate a live migration of a virtual machine by simply dragging and dropping the VM to a different host. Epicenter is displaying similar information as the current vCenter view, such as virtual machine name, current host, and status. It pulls this information directly from vCenter. However, since Epicenter is also managing the network switches, it has knowledge of the devices connected to the network, and it has located the virtual machines that are powered on. Epicenter displays the switch's IP address and switch port number where the virtual machine is currently connected to. The network admin has immediate visibility into the virtual server environment and knows where the VMs are located on the network. In this case, the Video Server W2K8 is located on 10.0.40.10, same information that is in vSphere client, but it also is on the 10.0.40.2 switch and is off of port 18. Currently, there is no virtual port profile associated with this VM. The map view in Epicenter displays a visual indication of the number of VMs on each switch in the network. In this case, in blue, there's one VM on each switch, and gives you a quick view of how many VMs are on the network and where they're located at. Virtual port profiles are centrally created and applied to virtual machines via Epicenter. This is done from Epicenter's Profile Manager. A virtual port profile named QP8 VPP has already been created. This virtual port profile simply creates a dynamic access list based on the source MAC address of the virtual machine and places the traffic in a high priority queue. To associate the virtual port profile with the virtual machine, you just right click on Associate, and select the virtual machine. And then hit Next, and then select Attach. And that's it. Now that we've assigned the virtual port profile or VPP to the VM, let's see XNV in action. I'm going to open the console of the virtual machine from vCenter and start the video stream. Now recall that the VPP that's associated with this VM prioritizes the traffic, and the traffic is traversing a congested link. So as long as the VPP is associated with the VM, then the VM's traffic will be prioritized. And this is the case with this video. And the VPP creates a dynamic access list on the switch which prioritizes the traffic. And the VPP follows the VM throughout the network. So the VPP should currently be on the switch that the VM is off of, and that's the Summit X650 24T. So let's take a look at the switches. As you can see, there's an access list on port 18, and that's the same port the VM is off of. Let's take a closer look at the access list. So here's the actual access list. It's based on the source MAC address of the virtual machine, and it replaces the diffserved code point and places the traffic in QoS profile QP8, which is the highest priority queue. Let's take a look at the other switch, and there's no access list on that switch. So let's go ahead and move the video server. So I'm initiating a vMotion from the .10 host to the .12 host. Now keep an eye on vCenter. The VM will move when the status is at approximately 78%, and once vCenter shows a move, shortly behind that you'll see that Epicenter will also detect the move and update its tables. The VM is moved, and Epicenter has now just updated its tables as well. So you see that the video server W2K8 VM is now on the .12 host, and it has moved. It was previously on the .2 switch, and now it's on the .3 switch, which is the Summit X650-24X, and it's off port 21. Previously it was off port 18 on the other switch. Now since the virtual port profile should move with the VM as well, let's take a look at the switches to see if that's the case. So there's no longer an access list on the Summit X650-24T, and now there's an access list on port 21 on the X650-24X, and that's the same port that the VM is on. As you can see, it's the same access list. Now what I'm going to do now is move the VM to the .11 host, and this .11 host is connected to the Summit X650-24T, but it doesn't have XNV enabled. The virtual port profile won't move, and so you should see that the video traffic and the video itself will be degraded. Okay, the VM has moved to the .11, and as you can see, the video quality is degraded since the traffic is no longer being prioritized. So if this was an actual VM move in a data center, the server admin would soon notice that there's an issue, and he would start having to troubleshoot the problem. Eventually he'd pull in the networking group, who would also have to troubleshoot the problem and locate the virtual machine in the network, and then also check the switches to make sure that the configuration is correct, if the policies are correct or even exist on the switch. And this is the type of issues that XNV addresses. So this concludes the XNV demonstration. Thanks for viewing.